Hello, so today's topic is the rib tool that's in the part design workbench of CATIA. So rib is a sweep or a form of sweep. The positive space counterpart is the rib and the negative space counterpart is the slot. They work essentially the same. One adds material, the second, the slot in this case, removes material. So I'm going to demonstrate the rib tool, which is the tool for adding material. Again, it's a sweep. So just a basic definition of a sweep. It's a profile that is swept or extruded along a trajectory. In this case, it's a profile that is swept along a center curve in CATIA. And there are three profile control options. You have keep angle, you have pulling direction, and you have with reference surface, and I'm going to demonstrate all three of those. So let me show you what I have on the screen here. I've got a sketch in this case that's going to serve as the center curve or the trajectory, and then I've got a profile, which is also a sketch, that's going to serve as the profile that's going to be swept. This is on a reference plane that's actually an angled reference plane. It looks like a normal reference plane, but it's actually I can adjust the angle of this, and you'll see why in a few minutes. But it's on a reference plane with a position sketch oriented off at the end of what's going to be the center curve. So let's get going. So I've got my part body activated. Notice I have a couple of geometric sets. One for the center curve, and the second one, which is this one, I should put it in here, is going to be for the profile, and then the rest of this is reference stuff. So let's go to the rib tool, which is a sketch-based feature in CATIA. So it's going to be on the sketch-based features toolbar. So select the rib, make sure it's going in the body, and it is. And I'm going to start off with the keep angle tool. And so I'll select for my profile this sketch, and for my center curve this sketch. And the keep angle, what that profile control will do for me is that will keep the same angle throughout the sweep. So it keeps the same angle to the center curve. And right now that angle is 90 degrees. My reference plane that I sketched upon is normal to my center curve. So it's going to keep that normality throughout the sweep. And you can see that whenever I preview, and I'm going to unhide the center curve, but it keeps that normal in this case. So you can see the end profile here. It keeps it normal. And it's keeping it normal because the sketch is starting out normal. So instead of normal, I should probably say 90 degrees. So it's keeping it 90 degrees. But let me show you how that can change. So I'll turn my profile back on. And there's my profile. And this is the plane upon which I sketched. So as I tap into this plane, you will notice that it is an angle normal to plane option. And I can adjust this angle. As you watch the screen, you can see that the profile is changing as I adjust this angle, just to show that it's a keep angle and not a normal profile control. So I will trick my students and say, one of the options, the keep angle keeps the profile normal to the center curve, which is incorrect. It keeps it at the same angle throughout. So right now I'm sitting here at 11-degree angle, the profile to the center curve, so it keeps that 11-degree angle all the way out, all the way through the sketch, all the way through the sweep. So very important concept. I wanted to demo that to you. I want to back this up to be back to 0. And that's the first profile control option, which is probably the one that you will use the most, especially as a beginner user of CATIA. And let's go to the second profile. I'm just going to change it. I'm going to keep this rib, and I'm going to change it to pulling direction. So what pulling direction will do is keep your profile normal to a selected plane as it sweeps. Now, a lot of CAD systems have similar capabilities. I've seen other CAD systems that will, with a similar concept, keep it parallel to a selected plane, but CATIA, it's normal to a selected plane. So the profile control, I'm going to change to pulling direction, and it's looking for, hey, what do I want to keep it normal to? So I left this plane, the XY plane, visible, so I can select it. Now when I do a preview, you can see that it's keeping the profile as it sweeps. It's keeping it normal to the selected plane. Powerful tool, powerful feature. Just got to be careful and make sure that you don't end up with any topological issues as it sweeps through. Not every plane will serve appropriately for pulling direction. You can also select lines as pulling directions too. I'll show that in another video. So that is pulling direction, simply pulling direction, a very simple look at pulling direction. Finally, let's look at the third profile control, which is with reference surface. Now this seems a little bit more obscure than the other ones, but it's very, very powerful, especially when you're doing surface modeling. But it could also be very, very powerful for part modeling as well. So what does that do? So what I'm going to show you, I've got this set up already, is I'm going to turn on a swept surface that I have. So you can see the surface. What I'm going to do is go back into my rib, and I want to change to reference surface. And I want to pick or select, this is my reference surface, and hit OK. You can see that now not only is the profile sweeping down my center curve, but the horizontal axis of my profile is staying at the same angle throughout the sweep that it originally stayed with the reference surface. In this case, it was lying on the reference surface. So that profile is going to stay on the reference surface as it sweeps through. You can see that on the bottom. So it's following that reference surface. Again, very, very powerful. I use that quite a bit in surface modeling, but it also can be handy in part modeling as well. So a couple more features that I won't demo, but at least I'll talk about with the rib tool. So let me get back into this. So the merged ends option. So notice this is an open sweep. In other words, it doesn't close on itself. The center curve doesn't close on itself. So if you are modeling a sweep in a body and the normal projection or extrapolation of the ends of the sweep would merge completely intersecting the current body or solid geometry in the current body, then you can turn on merged ends and it will extrapolate out and merge in with solid geometry in the current body. Much easier probably to demo, and I'll throw that into another demo later. But the merged ends allows you to extrapolate the ends of the sweep into solid geometry in the current body. And of course, then there's the thick profile option, which allows a user to enter a wall thickness. So very, very handy if you're doing something like a pipe, ductwork, or something of that nature. So if it's hollow on the inside, very, very useful just to go ahead and turn on the thick option. And with the thick option, as in most other thick capabilities of the Part Design Workbench, you have neutral fiber and also merged ends options available with that. So I hope that helps. So a very, very basic look at the rib tool. Similar capabilities in the slot tool. So I'll just tap on the slot tool and you can see that the dialog box looks the same as the rib tool. So similar capabilities, except the slot removes material and the rib as material.